I have to always adjust it right when it starts. Okay. Living the dream, living the dream, bro, aka, are you the Rotten Egg Nebula? Is that, which one is that? Honey, send me the thing in Discord if you can. If you want. One day we will see. Wait. It's my, wait, is it really? Is it really? God. It's not in here, but you gave me the information. Thank you, mods. I appreciate your help. Boobs, boobs, boobs. That's what that guy said. Wonderful. Not that kind of stream. Let's see. So, would it be under that? There he is. There he is.
All right, honest question.
Okay.
I got a headset.
Yes.
Is it work or am I like Captain Dorcas?
No. Well, what are you trying to say? What are you trying to say?
Like, are these headphones really dorky?
Well, I'm wearing headphones. No, they're not dorky.
They're not dorky. They work.
Not on Twitch. Like if
not on Twitch. So like in the real world.
In the real world.
It's way off. I can't walk down the street.
No, not without being laughed at. No, not.
Well, that happens anyway. So that's not new. But I don't want to add a new source of being laughed at.
Right. Yeah, no, I think you'd be fine. Those don't look, I mean, we can wait. What is chat saying? They are dorky. Don't listen to them. Don't listen to them.
See, I told you.
Don't listen to them.
I told you.
You can't listen to them ever. Guys,
except when I have to listen to them.
Except when you have to listen to them solely. They're your feedback. Let's see. Someone said
they are cheap $20 headphones. That's why they look like cheap $20.
No, but they sound better than what we had before.
That's because before I was just on like the earbuds.
Yeah. It's someone Hammy says it's a sophisticated call center headset.
Yeah. Hello, yes, may I take your call? What's your issue?
Call Astrophysicist, guys.
Yeah.
First thing. So I'm sure you could do troubleshooting. You know, you just need to ask people if their computer is plugged in.
Proteus Black, like the guy on Star Wars.
Mm-hmm.
Oh, like which one? The one that like does the Death Star lever, where he's like, ooh. That one. I want to be that guy. That's like my only job. It's to grab the handle and go. And then the giant laser goes.
Yeah. Walmart special. Someone said, actually, that would be awesome. I would call every day. Well, that's half the thing. So he actually has that kind of already. It's called Ask a Spaceman. Right?
Ask a Spaceman. I'm the spaceman.
He's the spaceman. He's an astrophysicist. So that means that he actually went to school for this, got his PhD. So he is a doctor.
In spaceman. PhD in spaceman.
Yep.
Yeah,
and so
from Hollywood Upstairs Science School.
Yep.
Mm-hmm.
So you guys can, there's all of the links right there. He's even on Twitch. And if I don't, I'm
literally on Twitch right now.
Yes. In two different channels. He has his own channel as well.
My own parallel.
Parallel.
Channels.
Parallel universes.
I could work at an airport.
Yes. Oh my God. These headphones are amazing. The possibilities. The possibilities.
So the dude that was on Cloud City, was it this guy?
Oh yeah. See, that's taking it to a different level.
Yeah. Yeah, that's him. Yeah, I'll do it so I can keep talking. There we go.
There you go.
Didn't he have like a wrist computer or something? It's like
because this looks normal. Wait, do you have infinity tattooed on your knuckle?
Yeah. Oh, actually, it's for the 8 people I killed in prison. But a lot of people think it's an infinity, like a marriage band or something. It's a common mistake.
It's a common mistake. Oh man.
Yeah, no, my wife has one too.
Oh,
We're
really?
married.
Well, yeah, I knew that, but
Yeah.
chat usually asks if they can marry you. That happens.
That is no, that's not legal yet. But I got some sister wives on the line that are ready to go as soon as Ohio lets it happen.
Wait, what is this Twitch? If you do the guest command, it has all the information. His Twitch is Paul Matt Sutter.
That's my middle name.
It even has his book in there. I mean, this is a very big link, a big command, but worth it. There's a lot of information in there.
It's juicy. So I finally got the cover art from my book. It's not on the Amazon link yet, but I got the cover art.
Is it good? Do you like it? Can you share it or no?
I got the cover art.
Okay. That's I'm picking up what you're dropping.
I was told it was the final version. And that they would hope I was as happy as the committee was.
Great. That's wonderful.
It's spacey.
Yeah. Like right now we're looking.
My name on it.
It's spacey. We're looking at the Egg Nebula.
The Egg Nebula?
Yeah. Do you see? Can you see like my screen? Even though you probably have me muted, do you see?
Actually, no. I just pulled up the chat, so I don't have you. But I'll look at the Egg Nebula. That's a pretty nebula. Looks like there's a bunch of shockwaves.
Yeah.
Going through it.
Do you think that looks like an egg?
Like a beaten egg.
I
wouldn't call that the Egg Nebula.
I would fail this Rorschach test. Like
this is hilarious when you look back at like who named these nebula. It turns out it was a bunch of people in the 1800s who had really, really crappy telescopes, and they got to name stuff. And they point their telescope at something and see like that kind of looks like a crab, I guess, crab nebula, and then everyone just agrees because everyone has the exact same crappy telescope.
Yeah.
And then 100 years later, we're like, that doesn't look like a crab at all.
No, I'm gonna go to it right now. Yeah, it doesn't look like a crab.
Not even close.
No, and of course this is a game trying to render that, but yeah, this, you know, it looks a little bit more hype in photos. But this doesn't look like a crab.
Not even close. Not even made of crabs. Crabs weren't even involved in its construction. It's just way off base.
And then someone said, yeah, it looks like I see an X-wing with the Egg Nebula. Yeah.
So I think, because I reject the authority of the International Astronomical Union, and
the IAU.
they claim to be in charge of naming things, but no one said that they could name things. They just said it for themselves. Like, we're in charge of naming things now, but like no one agreed to that.
And they also demoted Pluto though too.
What's that?
They also demoted Pluto.
Yeah, the whole Pluto fiasco. That was a hot mess.
It still is. It still is.
We're living in the hot mess right now. Can you feel it?
Oh yeah. It could be made of crabs. Someone says we don't know.
Actually, we can know. Because of spectroscopy.
Yeah,
spectroscopy
what is that?
We can figure out what stuff in space is made of.
And how?
Yeah, so this is something that we figured out in about the mid 1800s, and this concept 100% unlocked astronomy, where it transformed astronomy from. Can you tell when I get into topics that are chapters in my book? This transformed astronomy from just being like the positions of stuff in the sky to figuring out what stuff in the sky is made of, which is something we weren't capable of before. And spectroscopy is like so simple. Like every element, every molecule, every atom has a certain fingerprint of light, a certain pattern of light that it emits. It's based on quantum mechanical rules of that particular atom or element or molecule. And so you can concoct some substance in the lab. You have a gas of pure sodium, and you could energize it. You can see its fingerprint of light, and then you can look out in space, and where you see that exact same fingerprint of light, you know that there's a bunch of hot sodium there. Boom. You can figure out what stuff in space is made of. This is how we discovered helium. It was discovered in the spectrum of the sun before it was discovered on Earth.
Oh, I didn't know that.
We can look at the Crab Nebula. We can find the oxygen. We can find the nitrogen. We can find the water. We can find the hydrogen and helium. Ain't got no crabs.
This one says, I love spectroscopy. Wait, did he
Yeah,
get
you should.
headphones just for us?
I did
Mm-hmm.
actually, just for Skylias, not for you guys.
Not, yeah, just for me, guys. Don't take
And
away.
I got the second cheapest pair on Amazon.
Ouch.
I wanted to take it up a notch.
There you guys go. Um, so that way we can find aliens. Oh, well, okay. So speaking of a few things, um, I was gonna ask you, have you looked at the anything with regarding the Gaia data release too?
The datum, no, they released one bit of datum,
Mm-hmm.
and that was it. And that was very interesting. No, the Gaia has been flooding the archive. Do you guys know the archive?
I do. I don't know if people in chat do.
Put a link because it's spelled weird, of course. Whoops. What's happening? Oh, I'm not logged in. I should probably log in to Twitch.
Yes.
Here we go.
Well, like when you go to right now, I'm trying to go to the archive and it's just like doop. Nope, not doing it. Here you go. I think this is it. Is this the link you might see it. I'm posting it in chat right now.
So that's a bunch of papers released by Gaia. Whenever there are these big data releases by a major collaboration, they have all the papers they've been working on in parallel. As they prepared the data release, the data has been private inside the collaboration for all this time. And so all the members have got to pour over it, do some really cool basic research. And yeah, so there's a bunch of performance verification papers, which are kind of sort of interesting, various papers on how they process the data. And then there's going to be, it's not quite up yet, there's going to be a whole bunch of science papers from the internal Gaia collaboration. That it's going to be a bunch. I don't think there's going to be anything earth shattering, anything game changing, but there's going to be some really awesome science here.
Yeah, I think I found, wait, what is this one? This one is, because if you go to like their main page, it's not opening. I think that's one of the ones with the tools and the releases and stuff that actually contain the information. I think. You can correct me on that, but I just posted the other one.
Yes.
Have you heard of zombie stars? Someone just asked in chat.
I've heard this and then I forgot, so I have to Google search to reboot.
That's memory. Okay. I have to do that a lot.
So are these the stars that go supernova but then still hang around? They don't really die?
That's what I would think. The failed supernova?
A failed, they're not quite as bright as a regular supernova. And then usually when a star goes supernova, the progenitor is either completely destroyed or completely transformed into something else, like a black hole or a neutron star. But there are some cases where the supernova goes off, or something very close to a supernova goes off, but then the system is still hanging on. And then there's the potential that it can go off again. And what's interesting is this tells us a lot about how supernovas work. By looking at the examples of how supernovas fail, we get a better sense of the actual triggering mechanisms for real supernova. Because if we can see if there's any tiny little difference between the kinds of stars that become zombie stars and the kinds of stars that end up being supernova, that gives us a better hook for our simulations so we can get some handle on it. So yeah, zombie stars are real and they're really useful.
And how are they useful though?
By being able to help us understand how supernova works. So I don't know if anyone's told you, we basically don't understand how supernova work. We have the rough sketch of star explodes, and that's about it. When we actually try to put this into a simulation where we try to actually follow the physics from the state of a star through a supernova detonation and you pour in all the ingredients that you know a supernova needs. You know there's going to be a lot of conduction and heat transfer. You know it's involving plasmas and magnetic fields. You know there's going to be neutrinos and radiation transport. When you put all those ingredients in and you run a gigantic computer simulation, the stars don't blow up. They stall out, they like look like they're going to explode, and then they just kind of settle down. And it's very, very difficult in simulation, and as far as I know, it's still a relatively unsolved problem. It's very, very difficult to get a star to actually go supernova inside of a simulation, where the simulations are really just capturing everything we know about the physics happening inside of a dying star. And it's not exactly clear yet. There are some hypotheses here, but it's not exactly clear what's making these stars actually die. What is the actual mechanism to generate that shockwave that rips it apart?
And that goes right in line with what Marcus just asked. He said, so what is the deciding factor if it goes supernova or it turns into a black hole? Both would... Yes, you can answer that.
Yeah, we honestly 100% don't know. We think it has something to do with mass, that some stars go supernova and their remnant becomes a neutron star. Some stars go supernova and their remnant gets totally obliterated. And some stars go supernova and the remnant becomes a black hole. We think it's a progression in mass, but again, we're not 100% sure because it's such complicated physics. The last second of a star's life is a ferociously complicated event. It's hard to pin down. It's hard to explore this, what we call parameter space, of all the possible inputs of size and age and metallicity and you know, is there a companion around it, et cetera, et cetera, et cetera. All these little knobs to tweak that affect the outputs we don't fully understand.
That's actually a really good question because, yeah, we think it has something to do with mass, but I think we've seen things. I got a nice Einstein ring, by the way. I don't know if you noticed. You'll see that probably. Ooh. Yeah. This is looking at supernova 1997D. So for the year 1997, it would be the fourth supernova observed. Am I doing that right? A, B,
that is
C,
correct.
D. Yeah. Yep. That's how they name these. Does the star turn into a rock or does it break down to dust when it goes supernova? When it was determined, well, it depends on if it becomes a black hole versus a neutron star.
Right. So first we have to distinguish between the type 1A supernova and the type 2 supernova. And I'm very, very sorry about all this horrible astronomy jargon. I was not around 100 years ago when we were deciding all this. Otherwise, I would have suggested some better names. The type 1A supernova, these are the binary stars where a massive star orbits a white dwarf. The white dwarf builds up a layer of hydrogen from its companion star, reaches a critical threshold and ignites. We think those things just completely blow up completely. They just 100% annihilate and just evaporate. Mm-hmm. The other is the death of a massive star. These are the type 2 supernova, where what happens in the core is very, very interesting. Once you build up that core of iron and nickel, in the last stages of the fusion chain reaction, as you're going to higher and higher elements, heavier and heavier elements, you build up that core of iron and nickel, and you have all this weight of the star surrounding it that's just crushing it in. And nuclear reactions keep happening as those iron nuclei and nickel nuclei squeeze together. But instead of releasing energy, that nuclear reaction sucks away energy, so there's nothing to prevent further collapse. So it goes catastrophic, keeps pressing in, and in under those intense pressures, if there's any electrons just swimming around doing their own thing, the intense pressures shove them in to the iron nuclei, slam them into the protons. They merge with the protons and become neutrons, and also releases a bunch of neutrinos in the process. And so you convert this ball of iron into a neutron star, into or at least a proto-neutron star. And it's that neutron star that is able to resist further compression and what triggers the initial shockwave expansion. Then it gets fuzzy. Then it's hard to follow the physics of what happens to that shockwave as it passes through the atmosphere of that now dead star to create the supernova. But the initial triggering mechanism is the bounce off of that proto-neutron star. Now, if the infalling material is not quite powerful enough, then it bounces off the neutron star, and the neutron star stays and compresses a little and then becomes a normal neutron star. But in that moment of bouncing off, if there's enough material, it can compress the neutron star too much, and that's when it converts into a black hole at that moment of the birth of the supernova itself.
Hopefully that made, because I get that, but this this process,
it's tough.
Yeah, are something we need to understand before we can make a replicator like in Star Trek. What? Someone said I have one question which I've never got a good answer for. When black holes suck stuff in, it freezes in time from the outside observer. Then why do we see it, or do we? Shouldn't there be frozen in time black holes? I'm not sure.
I think I know what you're asking. Yeah, and so I know.
So
I know
wait, can
the
you
whole thing about? Let me go back to supernova. I know that was full of jargon and technical stuff. Supernovas are really complicated.
Yes.
And if you're not smart, you're just not going to get it. I'm sorry. That was the simplest I could. I mean, my kindergarten niece gets it. So if you can't, then that's on you.
Yes.
100%.
So what question do you think he's trying to ask? Because if he's talking about, I mean, if I were sending you into a black hole and I was observing from the outside.
I don't know why you went there for the example.
Okay, well, I can handle that on my own.
You had to make it personal.
Well, I wouldn't go there. I mean, I would just...
You'll happily send me.
Of course, for science. But probably the headset would go with you. Yes.
I'm taking this to the grave.
So
it is hot. Do your ears get hot?
Well, these are, I know. So that's why you invest. Usually that's why.
Oh, that's why you get the nice ones, so you don't get sweaty ear canals.
Right. Man,
I'm baking them.
So what, I don't think that's the question that was being asked. I think he's talking about, well, you tell me what you think he's talking about, first and foremost.
Yeah, so we if you were to send me, headphones and all, into a black hole, you wouldn't actually ever see me cross the event horizon.
Yeah, you'd freeze.
Would see me. Yeah, I would get slower and slower and slower, redder and redder and redder. From me, in my perspective, I would sail on through, but from you and your perspective, I would appear to be pasted onto the black hole.
Yeah.
And so the question here, I think, is, well, if everything that falls into a black hole is just pasted on the surface, what does that tell us about black holes themselves? Aren't black holes like kind of frozen in time, as it were? Like why should we even see in a growing or evolving black hole if everything just gets stuck on the surface? I think that's a question. Feel free to
let's see. Let's make sure.
666.
Thank you, Fengrash, for that. No time dumbing things down. Keeping is the individual's responsibility. That's exactly what I meant. Okay, so you are right. So so all the artifacts that are falling in, keeping like the accretion disk, he's asking if that accretion disk would be essentially frozen in time. Is that?
Yes and no.
Okay. All right.
Yes and no, because it depends on your perspective. Like all things in relativity, your perspective determines how you see the universe. And in a sense, all black holes are kind of frozen in time. And in fact, some people ask, and I'm pretty sure this is a related question. Some people ask, like, okay, if nothing can escape a black hole, then how can gravity escape a black hole? Right? How can if gravity is limited by the speed of light, and in order to escape a black hole, you have to go faster than the speed of light, then how could we have any gravitational interaction with a black hole in the first place? And the answer to that is the same answer as this frozen in time, is a black hole is a frozen in time object. You're not seeing the hole itself. You're seeing and feeling everything that, from your perspective, is pasted on the surface. The event horizon, one way to look at it is as like a line, a boundary in space-time. Another way to look at it is the shadow of the star that died to become the black hole. Right? Because if you're watching a star collapse, or that proto-neutron or star or whatever collapse to form the black hole, eventually it will shrink to a point where its radius is smaller than its short shield radius,
right?
And it becomes a black hole. But from our perspective, that surface of the star, that hot glowing surface, just gets redder and redder and redder and redder and slower and slower and slower. Eventually it becomes so red and so slow, it essentially looks black. So you're seeing the shell of that star. Apparently, look, it's stuck on the surface. And the gravity you experience, orbiting a black hole, near a black hole, doesn't come from the singularity at the center. It comes from all the material that's pasted onto the surface. That effect, and yeah, that's kind of weird.
That is kind of weird. And someone just said gravity isn't limited by the speed of light. Sad face.
It is. So gravity is curved space-time. You're absolutely right. But there are limitations to how quickly space-time can change. And if you like slap space-time over here, how quickly those changes can propagate to over there. And that speed is the speed of light.
A gravitational wave.
A gravitational wave.
Boom. And then Peter says, what are your thoughts on white holes, Dr. Paul?
White holes don't exist in our universe.
Boom. Another boom.
That's what I'm here for.
I see. Thank you. Yes, he's got his degree in astrophysics.
Spaceman studies.
Yes. He is the spaceman, and even more so with that headset.
I'm a stay-at-home astronaut.
I'm a stay-at-home astronaut. Me too, but not really at all.
Kapow. Can you do like cartoon like things so I can go kapow?
Like that? Like we do it? Are we fist bumping?
And then, no, and then there's like a thing, like the Batman thing that's just like kapow. Like I just did some. Let's skip that.
Like on Twitch? No, that's an extension that hasn't been created. Hey, programmers, if you're listening to that, we should make that a thing. Opportunity.
Megabucks here.
I knew you would shut something philosophical down. Well, it is one of those things that are, I get asked that all the time. People come in here and I start talking about black holes, kind of what we know about black holes, what we, things like this. Again, talking about that frame of reference and how it would differ, as you get closer and maybe someone's further away from the black hole observing you, and how frame of reference actually works. And then people are like, well, what about white holes? And that seems to usher in a lot of kind of the fake news that's around, and it's right. Interesting, but it's not as tangible as, say, like something like Hawking radiation, right?
Right, and I wouldn't call white holes philosophical. So philosophy, I love philosophy. I respect it as a profession. Science is actually a branch of philosophy. So if you ever see a scientist like bad-mouthing philosophy, like go ahead and slap them for me, because they deserve it. And they don't know like their own intellectual tradition. But I do shut down things that like don't exist in our universe. White holes are an interesting hypothetical concept, an interesting extension of the mathematics of general relativity. Turns out they don't exist in our universe, so that just personally doesn't excite me very much. And I don't see much utility in talking about them.
Right, right. And there's a few good questions coming in. Someone said, well, how many dimensions are there? 4.
4. Yeah.
Yeah.
3 is space, 1 is time.
Wait, 3 is space and 1 is time?
Mm-hmm.
Oh, you didn't just combine space-time?
Well, it's
you're right. Sorry, just joking. I know this.
Sorry.
You're
totally kidding. No, as far as we know, reality, all we need is 4 dimensions, 3 is space and 1 is time. They are totally intertwined into this entity we call space-time, but it's a 4-dimensional construct.
Yeah, no, we experience time. So
just like we experience space.
So these are yes, he is right. And a lot of people would say that, so we live in a 3D world, but we live in a 4D world. But we actually live in a 4D world. And that's where, I have to admit, that was probably one of the first things that I really got interested in with astronomy.
Oh, really?
Yeah. I would say that was the one that I was like, okay, that's kind of crazy at the very beginning. Because, so many people think like we live in a 3D world. And then when you start delving into astronomy and go further and further into the physics rabbit hole, then you find out, oh, okay, so other things have applied. Even though you learn some of these things in school, it doesn't well, I didn't have good teachers.
Get this, even Einstein had to learn it in school.
Yeah, really.
So Einstein, when he developed special relativity, he didn't realize that it implied this very powerful connection between space and time. And it was the person who did, after reading and following Einstein's work, it was a guy named Hermann Minkowski, who was Einstein's old professor.
Oh.
And Hermann Minkowski came in and saw this and said, oh, by the way, everything you're working on with that we're now calling special relativity shows that space and time are unified in a single fabric.
Yeah. I didn't know that, actually.
It's
wasn't he a pretty
nugget.
Was he I thought he was not that great of a student.
So Hermann Minkowski himself thought Einstein was kind of lazy.
Yeah.
Because Einstein thought he was above the material. Or let me say this. Einstein was interested in some, shall we say, speculative branches of physics at the time that weren't normally taught in the standard physics curriculum. So he was fascinated by electrodynamics. He was fascinated by statistical mechanics. These topics weren't really part of the traditional physicist education program.
Right.
And so when he was in these higher level classes, he wasn't super interested in, like, I don't know, the Poisson equation. Like, he knew about it, but it just didn't really get him going. It didn't get him out of bed in the morning. And so Hermann Minkowski was like, come on, you lazy brat, you're not better than us. Like, just learn the material. You gotta pass the test.
You got to do this. Someone asked, so we're kind of all over the place, but it's okay because I keep telling them, like,
this is great.
I do too. So someone said, and I feels terrible, man. I got your question, but I'm still going above it. So are there any new theories about those fast radio bursts, the FRBs? Like
Furbies.
Yeah, so maybe bursts come from supernova just before it becomes or gets swallowed by a black hole.
Yeah, Furbies are weird because we only have like a couple dozen. And by the way, Furbies are, as the name suggests, fast radio bursts. These are signals in the radio that are incredibly brief, like millisecond, microsecond long. And they don't just happen at one frequency. So they'll scan over a few different frequencies. Like they'll start at one low frequency, and then in that brief burst, they'll scan up to a different frequency, and then they'll go away. And we only have like a couple dozen known examples, which makes it really hard to do astronomy when you only have a couple dozen examples. And they seem to come from all over the sky, which tells us it's not coming from our own galaxy. It's coming from outside the galaxy. And it doesn't seem to be connected to any particular event. So if we see a Furby, then we go, oh, okay, let's go back in the records. Like, to that galaxy, did anything interesting happen in that galaxy? Is it an active galaxy? Was there a supernova? We go back, nope, nothing. it's just little bleeps and bloops in the radio that we don't fully understand.
Let's see. Well, then Feels Terrible Man said, I had to pause chat, said, this is for Paul. What are you currently working on?
So my own research. So actually, I do tons of outreach nowadays, like the podcasts and TV appearances in the book and all that. I do maintain a couple research lines nowadays. One is I'm very interested in the cosmic microwave background, the earliest moments of the Big Bang of the universe itself. And I was a member of the Planck collaboration that did a bunch of studies of the cosmic microwave background, this light from the early universe. I'm very interested in the large scale structure of the universe, how galaxies are arranged at the very biggest scales, and I'm very interested in the appearance of the first stars.
Someone says, could there theoretically be more dimensions?
Yes.
Theoretically.
There could be. String theory says there's a bunch of compact curled up dimensions. Some theories of how gravity works says there's a macroscopic, a large scale dimension that we're embedded in, and that's why gravity is so weak. There are ideas out there, but none of them have been verified by experiment.
And Shark Alligator came in with 100 bits. Thank you for that. Said, in quantum physics, it is said that the act of observing an object changes it. Heisenberg's uncertainty principle. Could this mean that by studying astronomy, we are changing the universe?
Yeah, I think the Heisenberg uncertainty principle is probably one of the most misapplied concepts in all of quantum mechanics, which is rife with misapplying. And the basic refrain I tell people is that just because things get weird at a quantum level doesn't mean all bets are off. And probably the best illustration of this is, are you familiar with the Schrodinger's cat experiment, thought experiment?
Uh-huh. Yeah, no.
Yes. Are you nodding your head? Because I can't.
I'm sorry. I was reading another whole question, but...
Oh, you were busy.
I'm sorry. I shouldn't be. I should be listening because I'm trying to field these questions. There's a lot coming in. I'm sorry.
Right here.
Okay.
I'm the guy with the headphones.
Right. Got it. Let's go.
We're good?
Let's go, champ.
No, you got a job to do. The Schrodinger, our Erwin Schrodinger put out this thought experiment, say, well, if you put a cat in a box and then you put some like radioactive poison that has a 50-50 chance of killing the cat, until you open the box, the cat is in this quote unquote superposition state of being both dead and alive. Then when you open it, that's when the whole system collapses and you're both dead. You're either dead or alive. And what a lot of people miss with the Schrodinger's cat experiment, thought experiment, is that this thought experiment is being used to demonstrate the absurdity of applying quantum mechanical principles to systems that are not quantum mechanical. What Erwin Schrodinger's point actually was like, no, the cat is either dead or alive. It's not a quantum system. It doesn't behave by quantum rules. Even if you don't open up the box, the cat is not in some vague quantum mechanical superposition between being both dead and alive. It's either dead or it's alive. You just don't know it yet. You can't apply quantum rules to non-quantum systems. So if I see a distant star, the act of observing that star doesn't change the character of that star because that star is not a quantum mechanical system.
Yeah. So someone said, are you familiar? Yeah, but we were, no. Okay. Sorry. So Schrodinger was a quantum troll.
Yes. He was also a genius and a founder of quantum mechanics, which afforded him the luxury of being a troll.
No cats were harmed with this thought experiment.
Yeah, I had to keep correcting myself. I kept saying the Schrodinger's cat experiment, but it's really a thought experiment. I'm sure someone somewhere has done it.
Yeah. Hopefully, PETA. And then it's someone said, if everything falls into a black hole and it grows, will everything in the universe fall into black holes? And will they grow into one big black hole?
The blackest of holes.
The biggest.
Yes. Yes, but no.
So am I going to guess it? I'm going to guess that you're going to say a lot of material will fall in there, but that black holes in the end are likely to evaporate potentially. Potentially. That's a theory that they evaporate.
Actually, let me modify my response. I'm going to say no, then yes, then no again.
So the first no, wait, let's see, will everything in the universe fall into a black hole? No. I would say no too. And will they grow into a bigger black hole? Yes, when galaxies merge. But galaxies are getting further away from each other, though. Except if you're already caught in the same sink like we are with Andromeda.
Yes.
And
so,
yes. Okay,
know,
you
right?
elaborate. You go.
Here we go. No. Wait. Was my no, yes, no?
Yeah,
That's
no, yes, no.
Okay, no. Not everything in the current observable universe will collapse into the same black hole. That's because the expansion of the universe is accelerating. On average, distant galaxies are being ripped apart from every other galaxy. We'll never, ever encounter them or be able to touch them. So there are some galaxies we can see today that we'll never be able to travel to. They will never reach us. We'll never collide. And thus, they could never fall into our black hole. But then, if you give the universe long enough, everything outside of our local bubble of the Milky Way and Andromeda, Triangulum, a few other galaxies, they're all gravitationally bound together. Everything outside of that gets ripped apart from us from the accelerated expansion. And our entire universe just becomes that one little glob. And slowly over time, there's multiple black holes in that glob, some leftover dead stars, some rogue planets, a bunch of junk left over. Slowly over time, this gravitationally bound structure will dissolve through chance interactions. Every once in a while, everyone will just get kicked out of the club, get voted off the island, and then as soon as it's ejected, it gets carried away until every macroscopic object in the distant future will be left to its own little bubble universe, where there will be a black hole confined to its own single solitary observable universe. There'll be no other macroscopic object in that universe. And so, yes, in that universe, in that bubble universe, that observable universe in the far, far distant future, there will be nothing but the black hole. And there'll be another little pocket bubble universe over here with its own black hole, maybe another little pocket universe over here with the leftovers of a planet, maybe down here, a neutron star. But then, so there's the yes, it will consume everything in its little pocket observable universe, but then through Hawking radiation, it will decay.
And evaporate away.
And evaporate.
And then someone said this is actually... Oh, I can address that when I have a question about stars when I was a little kid in the sky filled with white stars at night. Now I see less and less. Does that mean those stars went supernova? No.
You're just getting old.
Yeah. And you're not able to see as much.
Yeah, it sucks.
You probably should go get glasses or LASIK. But yeah, no,
it's just the older your eye gets, the longer it takes to respond to changes in brightness.
Yeah.
And you lose, you just like your hearing, you start to lose your ability to see dim things. So no, even I know it takes me longer at night to adjust to see the full night sky. And then there are some stars. A good test of this is to look at the Pleiades cluster. And the fewer stars you see, the older you get. Or the older you get, the fewer stars you see.
Yeah, and it's fuzzy.
It gets fuzzy.
It is very fuzzy.
And there's like nothing you can do about it.
Nothing. But yeah, that's supernovae are, if they are, of nearby stars, be very bright in our sky. So like when Betelgeuse goes supernova, if that were to happen in our lifetime, you would see that even during the day.
Yes. In fact, I think I happened across a random calculation of this. I don't 100% trust the calculation, but there is a chance it'll be brighter than a full moon.
Yeah, I've heard that, actually. Yeah. Because that guy is only like what, like 640 some light years away.
That's nothing.
Yeah,
It's down the street.
Yeah. If even that, have you even left your house? Do you think? I don't think we've even left the house at that distance.
That's the next room over.
Yeah, exactly.
Down the hall.
Yeah. So let's see. Someone said follow-up question on the black holes, frozen events on the event horizon. If everything that falls into a black hole from our perspective never reaches the inside, can we ever observe the increase of a black hole's event horizon radius?
Yeah. So this whole story of there's a black hole sitting alone in space-time doing its thing. Something falls in, me with headphones on, falls in, and I appear to get stuck and just paste on the surface, and I just get infinitely redshift and infinitely slow and infinitely dim and all that. That story is based on a certain set of physics. This certain set of physics, a particular solution to Einstein's general relativity, which assume that the black hole is static, that it doesn't change with time. It's just there, it's a feature, and then you're examining what happens to stuff as it falls in. And then you're asking, well, could we ever see it grow? Can we ever see it change? Well, the answer is yes, because really black holes are dynamical things. They really do grow. And at some point, a piece of material falling in and just getting stuck on the surface is indistinguishable, is mathematically indistinguishable from the same black hole you had before, just with a little bit more mass, with the event horizon stretched out just a tiny bit. And it's where those two conditions meet where we actually get an understanding of the evolution of black holes. I know I didn't communicate that very well. This is a concept that I can barely thread together in my own brain, but it's something that's in the mathematics.
So that's usually what you just got to say there is be like, it's in the math.
It's in the math. I don't know if you have a better way of
I usually just say
process.
No, I usually just say it's in the math. If it goes above my head, which a good portion of this stuff does, a very good portion. Wow, I have not scrolled down in a while. Let's see. So someone's asking about particle duality. So how have the concept that photons behave like a particle and a wave affected astronomy?
One of the best discussions on how light behaves is actually from a professor I had in my optics class. And I think he started out the class with is light a wave or a particle? The answer is it depends. It depends on the situation. It depends on the energy of the radiation. It depends on the medium it's passing through. And depending on what the answer is, depending on the particular situation, it affects the design of your telescope, your targeting strategy, how the radiation interacts with all the matter between you and the source of the event, and how the physics of the event itself. So it's kind of weird to think about a radio antenna, which is literally a piece of metal stuck in the ground, is detecting the same kind of fundamental object as Galileo's telescope, which is detecting the exact same kind of fundamental object as an X-ray detector at a doctor's office. They're all collecting photons. They're all counting photons. They're all counting, disturbances in the electromagnetic field. But over on the radio, it acts very, very much like a wave. Over on the X-ray and gamma ray, it acts very, very much like a particle. Visible light is somewhere in between, where you get some of the waviness and some of the particuliness at the same time. And that affects our instrument design, that affects our understanding, that affects how how the physics is done.
There you go. I'm new into astrophysics, and I don't know what exactly an event horizon is. Please explain. My 16-year-old me can keep up.
Don't ever walk through an event horizon.
You will not come back.
That's all I gotta say. That's
it is the point of no return.
You just don't.
Yeah.
I know it might look tempting, and all the cool kids are doing it.
Yeah. Ooh, that's a good question. Oh, that's a really good question. Can the first, because I mean, I've been waiting for someone to ask me this, but I'm glad you're here to do this. Can
Fair
the
enough.
first,
I'll let you take a first stab at it.
Well, can the first generation stars, non-metal stars, form black holes? Now, I'll let you take a stab at that one. That's kind of been, what are they calling those? Those, oh God, what am I thinking of? Primordial black holes, right?
Yeah, so primordial black holes are a very narrow hypothesis that is not exactly ruled out, but it's not favored because there's so many lines of evidence that point against it. Primordial black holes are thought to be black holes that are seeded in the early moments of the Big Bang itself and have persisted throughout time. We don't think if black holes were seeded in the early universe that if this event happened, it didn't make a lot of them. That's a different story. But the first generations of stars, so how does the universe produce black holes? It produces them through the death of massive stars. The first stars came online when the universe was a few 100 million years old. We're not exactly sure the numbers here. And we think those stars did generate the first generation of black holes. And what's surprising about the early universe is that we can go back to when the universe was just, say, 1 billion years old. So 12.8 billion years ago. And there's already fully fledged galaxies with supermassive black holes, with multiple generations of stars, with lots of metals and heavy elements in abundance. The universe grew up really fast. So in the first few 100 million years, there were multiple cycles of stars and black holes, to get us to a state when the universe is only 1 billion years old. It's already driving cars. It's already proposed. It's already has a down payment on a house. It's mature.
And so these first generation of stars were probably were they more massive?
Yeah, we think they were more massive. We're not exactly sure how much more massive. Different simulations, different estimates put anywhere between 50 and 200 times the mass of the sun.
And what generation is our star?
It's hard to say, how many parent stars our star had. It's classified. It's like third generation ish of stars. It might have had 5 or even 10 progenitors in the history of the universe. But in terms of astronomical classification, it's called population 1 because, don't get me started, but it's like the third generation of stars in the universe.
And do they determine this by its metallicity?
Yeah, by the number of heavy elements, which astronomers decided anything heavier than helium is a metal because they're idiots.
Yep.
I don't know, but that's the terminology we have.
So hydrogen and helium are not counted as metallicity, guys.
It's like, to an astronomer, there are 3 elements in the universe: hydrogen, helium, and metals.
Yeah.
I don't know. I don't know.
I tell them that all the time when we say, when we talk about that. So, does the universe expand faster than the speed of light? Yes. And how, if so, how? I answered the first part. See, I just said yes.
Okay, so you said yes, and then I have to say why.
Then you have to say why. Magnetic fields. Kidding.
Magnetic fields. Yes, the universe expands faster than light. In fact, there are galaxies that we can observe that are receding away from us faster than the speed of light. If you put down a giant rubber band between you and me, and started stretching out that rubber band, what?
Are you talking about the rubber band? I have the rubber band.
Do you have a rubber band?
Yeah, with marks on it too.
Oh, that's great.
Yeah, to represent galaxies.
Those are galaxies.
Yeah, these tick marks are galaxies.
Okay, I believe you.
Okay.
And yeah, so as you stretch out this rubber band,
Uh-huh.
initially when two galaxies are close to each other, they're not receding away from each other very quickly. But then as there's more and more rubber band between them, and the expansion rate stays constant, they will recede away from each other faster and faster. Eventually, if you were to stretch out that rubber band to ridiculous proportions, eventually the opposite ends of the rubber band would be moving away from each other faster than the speed of light.
That's the best explanation I've had with that rubber band.
That's great. I'm glad you had that prop.
Yeah.
What other props you got in there?
I got Plato to describe, how solar systems form and accretion of, protoplanets and things like that,
I like it.
I don't have a lot. I have a spandex hula hoop that has spandex over it to talk about.
That has nothing to do with science. That's something else.
No, that has everything to do with science. Is someone knocking at your door?
I don't believe you.
Well, yeah, no, it's talk about the stretchiness of space-time, the fabric, and how like a massive object makes an indentation in that spandex. Yeah, and then you can roll marbles across it. So I can use something like this, which looks like this is straight out of the movie, The Labyrinth movie. But you can have a massive object and show people how things orbits work and everything like that. So that's why I have that. But I need like
I'm looking at what I have. I have petri dishes with like food coloring and lasers. Let's talk about scattering.
Okay, so
light.
lasers are cool.
Vacuum chamber.
Oh,
maybe next week I'll have to bust out the vacuum chamber.
I think I've seen. Wait, do you do like the shaving cream thing?
That is a horrible mess. So I do not do the shaving cream. I tell the undergrads to do the shaving cream, and I'll let them clean it up.
You troll.
I do balloons. I can do an alarm clock that goes silent. I can boil some water. I can do some fun stuff.
Someone just said, boiling water is good for explaining how convection works. Space expands not at the speed of light or at any speed at all. It expands at the speed per distance, or in other words, expansion is measured in units of s to the -1 inverse seconds are not meters seconds. What?
So the expansion rate of the present day universe is somewhere around 70 kilometers per second per megaparsec, which has units of inverse seconds. It's just a convention. Which is exactly like if you were to pull apart that rubber band at a fixed rate, that would give you a speed to any other part of the rubber band given the distance to that part of that rubber band.
So someone says, so does the black hole just soak up all the energy and matter that goes into it, or does it dissipate, or what exactly is happening there? It totally sucks it up.
Totally. And it might let it go with Hawking radiation.
And you can see certain, emissions and different wavelengths, right?
Hawking radiation is something like 1 photon a year. It's like super slow.
It's pretty slow.
I mean, that's slow.
Yeah. And
so you gotta wait a while.
You gotta wait a
while.
Oh, someone makes a good point. They said metallic hydrogen, because I've been talking about how Jupiter can with its pressure, create metallic hydrogen. So yeah, but it's a metal, non-metal.
Right. So elements can take on metallic properties if you subject them to different conditions.
Yeah, enough pressure can do that. But that's
so we just got helium left.
We just got helium.
Just helium. Or helium.
I'm boiling water now for a cup of tea.
But are you doing it in a vacuum?
Yeah, are you doing it in a vacuum? That's
are you doing it at room temperature?
Do you want to describe to people what room temperature? So do you want to tell people what a vacuum is?
A vacuum is when there's no air.
Nothing for no medium?
No stuff.
No stuff. So is there sound in space?
There's no sound in space.
Why is that?
Like the sound of your own heartbeat. Because sound is disturbances of air. These are pressure waves. When I speak, my my larynx vibrates, it pushes on the air molecules, wave back and forth like this, and then they do something, they hit a little resonator in there that translates that into an electronic signal that's sent to you, and then the speaker vibrates like that and jiggles around the air molecules, which then hit your eardrum. Your eardrum jiggles around, translates that into an electrical signal, which you interpret as me talking. All that requires actual air to move around. You take away the air, and my larynx isn't pushing on anything. It's just sitting there, wiggling, minding its own business.
Ooh, I like that. So Eludriel asked a really good question.
Yeah.
Because it's kind of almost like, I don't know, would you say that's a paradox almost? So if you're falling into a black hole, and I talk to people about this a lot, you know, how I would observe you, right? And you would appear frozen at some point to me if I was sending you into a black hole and I'm sitting back on a spaceship far, far, far away, just watching you do this, you know.
No, come closer.
Nope, I'm not doing it. And I'm just going to stay back here. And that's fine. I am comfortable. I'm very comfortable. I have brownies.
We have better ones right over here by the black hole. Just like right.
I would make sure that I had all the food on that ship because this is going to be a long observation.
But you didn't pay close enough attention to the cheese.
I'd make sure I had that too. So you're falling in, but from your frame of reference, if you get closer, as you get closer to the event horizon, if you turn around and look at me, to you, from your frame of reference, time is going to go by. You're going to experience...
Right. So if I am freely falling into a black hole, if I'm just letting the black hole take me, I experience a little bit of time dilation, but I don't experience the most of it until after I've fallen through the event horizon. The whole being able to watch the sped up universe, witness the future history of the universe run past you. That's if you're hovering at the surface of the black hole,
right? And
you're firing your jets, and the closer and closer you can get right to that event horizon, the faster everything else appears. And yeah, you could hang out there, and then eventually the black hole would evaporate and go away, which is fine because you never fell in.
That's what he said. That's why I loved that. That's amazing. I know that I would never use that. That's what he said. I'm not used to using it like actually accurately. Usually I'm saying that in a complete meme way.
That's literally what he said.
But he was like, so would you ever actually fall into it if you were able to get to that point, which it is, like as you get closer to the event horizon, you would notice, like he said, a little bit of that time dilation. But getting at that point where you're above it, you could observe the universe going by. But if you saw that, then the black hole would go with it.
Yep.
Wouldn't we call that a paradox?
It's no paradox. You're cool.
It's okay.
We're clean. We're
good. I was like, can we not?
Checks out.
So you have about a minute left because that went by fast. Everybody, and I apologize, guys, for all the questions. I'm trying to pick a few ones. We talk a lot about dark energy and dark matter. I want to talk about other things. But it doesn't mean we won't talk about that again.
We got more weeks.
Yeah.
This isn't our first time together, folks.
And is it okay if I still follow up with you about our email earlier with because I'll find out today about the...
You find out today?
Today at the end of the business day, I can call and see if I'm selected.
I hope you don't, because I wouldn't want you in my jury.
Thank you. I send you into a black hole. It's completely fair.
Fair enough. And it'd be really fun to bring you on the radio show and see if any of these people in the chat are actually willing to pick up a phone to talk to you.
Oh man, guys. Yeah. I don't know. That would be interesting. I'm curious to see how many people would actually call in.
Yeah. We're going to record the tape in case we need to edit anything out.
Yeah. Because
of public radio.
Right. So it would be edited. So if someone wanted to call and troll, then we would just edit that out.
We also have a producer that's screening calls. So it's like, and I got a fast reaction on that mute button. You have no idea. Like, bam, you're gone.
Yeah. By phone. What's that?
Just a phone.
Yeah. No,
it's the other thing that your pocket computer does.
Right. It still calls. It calls people. That was originally its intent.
Crazy.
It's so weird. And so that's
what
a thing.
What will they think of next?
I know. When that would be upcoming, and I'll keep you guys all posted on that. Hopefully I don't have jury duty, because then also my stream suffers. Everything suffers. I know it's a part of this gig. But
especially the perpetrator.
Right. I'm hoping that I don't get called. I don't know the statistics on that, but I've been tempted to go and be like, okay, so what did they start with? Where do we end up with this? And like run the math on it. But I don't want to, that's not conducive to anything.
I doubt you'll get selected because you're pretty smart, and they'll recognize smartness and they say, no way.
Yeah, I don't know. They've selected me a lot. So
really?
Yeah, this is not, I've been called for,
no.
yeah, I've been called a lot. And just in the last 4 years, I thought there was something to protect me from this, but, so thank you so much. And we will have him back on, guys. He is a regular on Tuesdays unless something comes up with his schedule or my schedule. But, if you guys want to follow him
so far.
Yeah, we've done great so far, and I'm staying around, so I'm not done yet. But he's definitely going to be going, and so everybody could say bye, Dr. Paul. We'll see you next Tuesday.
Bye, guys.
All right, thank you. And let's say, so guys, follow him if you want to. He does his